Hello, my dear students and the rest of the learners. Welcome to part 5 of an 8-part series of tutorials in Fundamentals of Developing Computer Program, with our focus in this presentation being program testing and debugging. My name is MemGM, or you can simply call me Emily Swap. In this presentation, we are going to look at the introduction to program testing, the program testing methodologies, the levels of software testing, the types of software testing, stages of testing data, program debugging, types of errors, debugging requirements, debugging steps, debugging techniques, and debugging principles. Let's begin with the introduction. What is program testing? Program testing is the process of finding out whether the program content is working correctly and verifying it to ensure that it works as required. Therefore, after the code is developed, it is tested against the requirements to make sure that the product is actually solving the needs as addressed and gathered during the requirements phase. This testing and verifying of the program requires testing the completed program to verify that it works as desired. Therefore, you should not rely on just one test case, but should run the program several times using different sets of data to make sure that it works correctly for every situation provided for it or provided for in the algorithm. For this reason, program testing involves creating test data designed to produce predictable output. The three general categories of test data that a programmer can use are the normal data, the extreme values, and exceptional data. So what is normal data? Normal data includes the most general data for which the program was designed. That is the actual data that is used to check for the actual results. The extreme values are those values that are used to test the behavior of the program to see when valid data is either too high or very small. I repeat, extreme data normally involves the entry of values that are either too high or too low in order to see how the program will behave. On the other hand, exceptional data is entering illegal data that is not within the range or a class of inputs to see if the program is capable of rejecting it rather than attempting to process it to avoid getting wrong results. A test plan of the program has been done at the stage of the program design itself in order to ensure that you have a thorough understanding of the specifications. In this case, the most trivial and most special cases should be identified and tested, including the maximum and minimum values of all variables as test data. Therefore, once an algorithm or a program is developed or written, the next stage is to check that the algorithm or the program is doing what it was designed to do and is doing it correctly. Testing is thus done by the tester to identify the defects in the program. A defect in a program is a situation whereby the actual result of test case execution does not match with the expected result. So what are some of the program testing methodologies? The following are some methods or techniques that can be used to test software or software testing methodologies. Number one is black box testing. Black box testing is also known as closed box, the data-driven or functional testing. It is a method of testing a software whose one has no knowledge about its interior structure, architectural design by just interacting with it through its user interface. The user makes an input and then examines the output in order to see whether it meets the expectations. It is used to test the functionality of the program by providing input values and comparing the output to the desired results. It's mostly applied in testing the program's user interface Some test design structures or some test design techniques applied include equivalence partitioning, boundary value analysis, cause-effect graphing. It is performed by end users, testers, and developers. The other method of testing or type of testing is white box testing. White box testing is also called open box, glass, clear box, transparent box, structural, or content-based testing. This is a method of testing software whose one has full knowledge of its internal structure, design, and coding. It also wants to be able to find out the type of data that can help in testing the application effectively, even though it is costly, because it requires to be performed by a skilled tester. Some test design techniques used include control flow testing, the data flow testing, the branch testing, the path testing. The other type is gray box testing. It is also called translucent testing. It is a software testing method which combines both the black box testing method and the white box testing method. It is therefore a method of testing software whose one has limited knowledge about its internal workings, enabling him or her to have access to design documents. It also enables him or her to have access to the database, thus enabling him or her to prepare better test data and test scenarios while making a testing plan. It is applied to not only test the user interface, but also test the design documents and the database. The other type is Angelo testing. Angelo testing is a method of software testing whereby the programmer tests the code quickly and continually as he or she develops the program. Therefore, program development and testing happen spontaneously as teams collaborate if they are working on the same program. Some of its benefits are that it allows teams to find and fix defects early, helps get the software to market more quickly. It involves collaboration between developers, testers, and domain experts, and it allows for more flexibility. It is therefore based on the 4 key values. That is, individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, and responding to change over following a plan. The other type is called ad hoc testing. This is the testing of software that is performed without any specific test plan or predefined set of steps. Instead, testers use their intuition, experience, and creativity to identify defects and issues that more formal testing methods may not find. Some of its advantages are it can be implemented in a short amount of time, can be performed at any point in the program development lifecycle because it does not need to adhere to any process, can be performed by developers. Testers can identify more flaws than traditional testing because of the many cut-edge techniques that may be used, and can help deliver a quality program on deadline, even when in-depth testing is needed in a short amount of time. So what are the levels of software testing? Regardless of the method and technique used to test the software or program, testing takes place in the following 4 levels, or what we call levels of software testing. Number 1 is unit testing. This is the testing of an individual function, method, or a module in order to verify that the individual pieces of code are working correctly. The objective is to identify and eliminate execution errors that cause the program to terminate abnormally and logic errors that might have been missed during the desk checking. It is implemented by writing unit tests as you develop new features. Then you use these tests to catch and fix issues early before they affect other parts of the application. This kind of testing helps to test each module separately. The second level is called integration testing. This is performing a test on a combination of all the units or modules of a program in order to see how they work together smoothly. It combines all the units of a program and tests them as a group. This helps find the interface defects between the modules and the functions. It is implemented by running integration tests after merging new code to check for issues that arise from interactions between different parts of the system. The third is system testing. This is a test which is performed on the final program in order to validate its overall operation and detect any issues before production. It tests the software's overall functions. This type of testing checks the behavior of the application, software design, and end-user expectations. It makes sure that the entire program works as per the design and involves both the users and the developers. Number 4 is acceptance testing. This is a test which is performed on a program in order to verify that the software has been built correctly and meets the user requirements. It's the final level of testing and is done to catch both functional and cosmetic defects. It tests the software based on the user feedback. This test ensures that the program meets end-user expectations and requirements. It ensures that the software is ready for delivery, meets the end-user's needs, and complies with business criteria. So what are the types of software testing? In addition, a programmer can undertake the following types of software testing. Number 1 is functional testing. Functional testing fulfills business requirements. It uses both automated automated and this test. I repeat, its use is both automated and this test is carried out to confirm that the software meets user requirements and behaves as expected. It ignores the internal parts and focuses only on the output in order to check it if it is as per the requirement or not. It is implemented by testing new features during each sprint to ensure manual testing methods to cover all functional aspects. The second one is regression testing. This is a test which is carried out to verify that the new changes haven't broken existing functionality. It ensures that new features and updates don't negatively impact existing functionalities. It is implemented by using automated regression tests to easily or to quickly check that previously working features still function correctly after updates or bug fixes. Automation testing tools are used for these types of testing. Another type of testing is called exploratory testing. This test is carried out to discover unexpected issues through real-time testing and exploration. It is implemented by performing exploratory testing by designing and executing tests on the fly based on your knowledge of the product to uncover issues that formal test cases might miss. The fourth type of testing, or the fourth testing, is performance testing. This is a test which is performed to evaluate how the application performs under various conditions or under particular workload in order to help ensure that the responsiveness, the speed, scalability, and the ability for a program is there. It is thus done to check whether the program meets the performance requirements. It is used to identify and address performance bottlenecks. The fifth type of testing is smoke testing. Smoke testing is a test that is carried out to validate a new software build in order to ensure that no major issue exists in it once it is provided by the development team. It is used to quickly check if the basic functionalities of the software are working after a new build or update. It is conducted at the start of each testing cycle to ensure that the system is stable enough for more detailed testing. The sixth type of testing is security testing. It is used to check software for any loopholes that might be penetrated through any hacking and other issues that could compromise data and put in place strategies to ensure that an attack never happens. It determines how data is protected and used and whether it's secure. The seventh type of testing is alpha testing. This is a type of acceptance testing that is done internally within the organization before the product is released to others or to customers. The eighth type is usability testing or user-friendliness. This is a test used to check program flow in order to know if a new user can understand the application easily or not. It ensures that the proper help document is prepared if a user gets stuck at any point. Basically, system navigation is checked in this testing. So what are the stages of testing data? The following are the key stages that are used in testing data. The first stage is desk checking. It is also called tracing, manual testing, or trial running. It entails reading through the program while it is still on paper before entering it in the program editor so as to detect any obvious syntax or logic errors in the program. Tracing involves executing the program manually using input values for variables and recording what takes place after each instruction is executed. Number two is translator system checking, or what we call attempt at translation. The translator is invoked to detect any syntax errors that may be existing in the program, and then the programmer corrects these errors and submits the program until an error-free listing is obtained. The program is thus run through a computer using a translator program. Number three is program run with test data. Here, we test the program using sample data. This is carrying out trial runs of the new program using various data variations and the extremes of even data with errors so as to assess whether the program will be ready to help or it will inform the user about the abnormality and request for the entry of the correct data. Test data is also used to verify that the program is doing what it was supposed to do. A good program should not crash due to incorrect data entry, but should inform the user about the anomaly and request for the entry of the correct data. Number four is user or using debugging utilities, or what we call diagnostic procedures. This is running diagnostic procedures such as trace routines during translation to detect syntax or logical errors in order to correct them before execution. A trace prints out the results at each processing step to enable errors to be detected quickly. If a trace is not available, the programmer can insert instructions in the program to print out immediate results at key points. The fifth stage, or number 5, is system testing with action data, or what we call testing by users. As part of the acceptance trials, new programs are usually run in parallel with the existing system for a short time so that the results can be compared and adjustments made. The system test is made using action data. Let's now look at what we call program debugging. Debugging is also known as program validation. It is the process of rectifying errors or bugs detected during testing and the compilation of a program. Therefore, a bug is an error in a program that may interfere with its operation. When a program compiles without any syntax errors, but does not perform as expected when it runs, the program is said to have a bug, and you have to debug it so that it can give you the expected results. This kind of an error is said to be a logical error or a logical bug. The types of errors or bugs in a program are mostly of 3 types. So you can encounter the syntax errors, the semantic or logical errors, or the runtime errors. What are the syntax errors? Syntax error is an error in the grammar and the structure of the instructions of the programming language. This is in terms of spelling, punctuation, naming of variables, and other conventions that must be obeyed by the programmer while using a certain programming language. These errors are detected by the translator and must be corrected before the program runs. Number two is semantic or logical errors. These are errors in reasoning, such as incorrect sequencing of instructions and flawed comparisons and selection statements, which make the program not to function as expected by producing incorrect results. The logical errors do not stop the execution of a program, but the results may be inaccurate and can only be noticed and corrected by the user himself. They are not detectable by the translator. For example, numbers might have been subtracted instead of being multiplied. The third type of error is the runtime error. These are the errors that occur during the execution or running of the program after the program has been tested and debugged, such as the program testing stuck, or such as the program getting stuck in an infinite loop or entering wrong type of data. These errors stop the program from continuing execution because of wrong type of data being entered. The runtime errors occur due to the computing environment in which the software code runs. Examples include insufficient memory space or stack flow. You can resolve runtime errors by surrounding statements in try-catch blocks or logging the exception with an appropriate message. So what are the debugging requirements? What do you require to debug? For debugging to be successful, you require to have the following debugging requirements or debugging things or items. Number one are the debugging tools. A software tool to help identify coding errors during the development process. Debuggers can analyze test runs to see which lines of code were not executed. Number two are the breakpoints. A common debugging event that instructs the debugger to stop at a specific code location. This allows the user to inspect the application's state. We also have the reverse debugging. It is also known as time travel debugging. This technique allows developers to record, rewind, and replay their code. This can help developers find and fix bugs more quickly. The fourth one is reproducing the bug. Before changing code, it is important to reproduce the bug. The fifth method, or the fifth type, is understanding stack traces. Understanding stack traces can help with debugging. Then we also have writing a test case. Writing a test case that produces or reproduces the bug can help with debugging. What are the debugging steps? Once you've made the debugging requirements, you can then follow the following steps to debug your program. One, gather information about the error. An experienced programmer often knows where errors are more likely to occur based on the complexity of sections of the program, as well as the possible data corruption. Number two is isolate the error. Identify what portion of the program is causing the error. Number three, examine the error symptoms. One has to successfully identify and understand the symptoms of the issue in the code, such as crashes, error messages, or unexpected behavior. Number four is to identify the error. Determine the actual error or bug, which might involve other sections of the program. A bad identification of an error can lead to wasted developing time. Number five is to identify the cause. Once the symptoms have been identified, you must find out the other cause of the problem. This is done by tracing the code's execution and discovering the specific lines that are creating the issue. Number six is to determine how to fix the error. Here, you determine how the problem can be fixed. So determine how to fix the error. You determine how the problem can be fixed. Number seven is fix the error. You make the necessary changes or corrections to remove the problem and ensure that the code works correctly. Number 8 is to test the program. After the fix has been applied, it is important to test the program again and determine that the fix handles the former problem correctly. This testing is done to help find out if the fix is handling the original problem correctly and to make sure that the fix hasn't created any undesirable side effects. So the next step is to test the data. After the fix has been applied, it is important to test the program and determine that the fix handles the former problem correctly. This testing is done to find out if the fix is handling the original problem correctly and to make sure that the fix hasn't created any undesirable effects. So what debugging techniques do you need to apply? The following are some of the techniques or strategies that you can apply to debug your program, or what we call debugging techniques. Number 1 is understanding the problem. Determine what the expected output is, what the actual output is, and when and where the error occurs. Before you start making changes to your code, it is vital to fully understand the problem that we are trying to solve. Try to reproduce the issue and gather as much information as you can about the behavior. Number 2 is using debugging tools. These are the tools which give valuable insights into how your code is functioning, including variables and the memory usage, which help save a lot of time. And debugger allows you to inspect and manipulate your program while it is running. You can set breakpoints, step through the code line by line, and watch the values of variables. Profilers assist developers in analyzing the overall performance of their code and pinpointing any potential bottlenecks. Number 3 is making use of log analysis. Using logging and print statements can be used for tracing logical errors. It is a good idea to place log analysis statements in a strategic area of your code to provide valuable information for your debugging investigation. By understanding more about your code's execution flow and the values of variables at different stages, you are better equipped to identify the issue. Print debugging is a technique for debugging software by inserting print statements into the code to display the values of variables and the state of the program at certain points in its execution. Number 4 is problem simplification. Gradually remove parts of the code that aren't relevant to the bug. Number 5 is static analysis. Static code analysis tools examine the code without executing it to find out potential errors. The 6th one is setting breakpoints and stepping. It is a good idea to set breakpoints in your code where you think the issue is. A breakpoint is where you are able to temporarily stop the execution of your program to give you time to inspect the state of its functionality. The use of the stepping techniques to move through each line of the code to study variables and data structures of problems, or then use the stepping techniques to move through each line of code to study variables and data structures for the problems. This entails manually inspecting each line of code at a time before moving up or down to the next. Number 7 is taking breaks. The debugging process can be mentally taxing, especially when you are stuck on a problem. Taking breaks and stepping away from the code for a while can clear your mind and give you the opportunity to let thoughts and ideas simmer. This can potentially lead to breakthroughs because returning with a fresh perspective often helps you see the problem from a different angle. The 8th method, or the 8th way, or number 8, is backtracking or backward debugging. This method is useful for small programs. It involves identifying where an error occurs and analyzing the code backward to find its cause or its source. It involves starting from the point where the problem first began and working towards and working backwards through the code to find out how and why it happened. The ninth method, or ninth way, or number 9, is binary search. Binary search is where you divide the code into halves and systematically narrow down the location of the bug. Techniques such as commenting out bug or commenting out the code using print statements or isolating components can help you isolate the problem area quickly. Number 10 is clustering bugs. If you receive many error reports, it is better to group them into classes of related bugs, as bugs in the same class will often share common causes or similar patterns. Fixing one bug from a class is likely to resolve others, or at least give insights into how to fix them. The 11th method is called rubber ducking. Many developers find that explaining the problem to someone else can help them identify the issue themselves. The act of articulating the problem out loud or written down forces you to think critically about it. This process often leads to the discovery of new insights and solutions. The 12th way is doing what we call remote debugging. Remote debugging is the debugging of an application running in a separate environment from your local machine. For example, you may use debugging tools installed remotely to solve the bug. Remote debugging is thus a process where debugging is performed on a system different from where the debugger is located. The 13th way is called cloud debugging. Debugging complex cloud applications is challenging because developers have to emulate cloud architectures on local machines. Over time, configuration differences can arise between the local or between the cloud environment and the emulated environment. This results in more bugs in production and longer development cycles. Special tools are required for more efficient cloud debugging. The 14th way is learning from each other's debugging session. As you embark on your debugging journey, of which there will be plenty, it is not a bad idea to document the process and the solutions you discover. This serves as a valuable resource for future debugging challenges you might encounter. Each debugging experience will help you grow as a developer and enhance your overall problem-solving skills. The 14th method is learning from each other debugging session. This is just a repeat to show you how important it is for you to learn from each other, because by so doing, you are able to help each other grow as a developer and enhance your overall problem-solving skills. So what are the debugging principles that you need to apply? To be able to debug your programs successfully, you will need to be guided by the following debugging principles. Number 1, recognize the bug. Identify that something is not working as expected. Number 2, establish causality. That is, reproduce the error and understand what is causing it. Number 3 is to isolate the source. Find the specific line or section of code that is causing the problem. The next one is to identify the cause. Determine the root cause of the error. Then determine a fix by coming up with a solution to the problem. Apply the fix and test it by verifying that the fix has resolved the issue. Document the process. Remember, always keep a record of the steps taken to debug the issue. Then construct a timeline. That is, use debug tools like console logs, breakpoints, and data debugger etc. so that you can narrow the error. Then start from a herald point. If something is suddenly broken, try to find a branch or a point where it used to work and start from there. Then isolate. If possible, run just the code that is failing in another file or a folder so that you do not have the overhead of running the entire app test ideas. You also need to understand inputs. If the issue seems to be somehow directly related to inputs, start from the minimal expression of those inputs and progress towards the full set of values. This happens a lot when we have web requests with a bunch of data in the body. Always challenge your assumptions. When you are on an end row, review and challenge your assumptions. When you are trying to understand something at the beginning, you make some compromises on your assumptions that lead you to an end arrow or end row. Then unblock yourself. Following some principles and having the proper mindset doesn't guarantee you results. Sometimes you need to realize that you are blocked and you have to do something about it. Then know your own limits. From time to time, you will face a problem that is beyond your capacity. You have made the effort, but it is not enough. You need to calm down and understand that the most important thing is not your ego, but actually solving the issue. After that, seek help from your team or people in your company with more knowledge or experience than you. Then find ideas in diffuse mode. The best way to find new ideas is to enter the diffuse mode, which is basically giving your brain some room to go and find new ideas by doing some simple tasks like walking, washing dishes, going to the park, painting, etc. Then find the solution by explaining. Using the rubber duck technique or pairing with someone to explain your issue out loud is incredible, the amount of perspective that you can gain by structuring an idea or a problem so that you can explain it to someone else. And with that, my dear students and the rest of the learners, we have come to the end of part 5 of this series. You can now proceed and listen to part 6 of 8 of the series, in which we are going to learn about program implementation and maintenance. Congratulations for learning part 5 of 8 on program testing and debugging in Fundamentals of Developing Computer Program. You can access the rest of the parts in the series as well as other computer or ICT videos by clicking or tapping on MLSwap ICT YouTube channel below this video. To subscribe to the channel, tap on subscribe button below this video in YouTube if it's not currently reading as subscribed. For any further correspondence, kindly write to us through the email mlswap@gmail.com. Thank you very much for listening to me. Let's meet in part 6 of the series, and God bless.